Hello everyone and welcome back to Vector Academy. This is Satyatej and today we will be starting a new concept called quadratic equations. This chapter will be covered in 4 classes. One will be on roots of a quadratic equation, second will be on location of a roots and a graphs of quadratic equation. Third and fourth will be on mainly problems, but there are some miscellaneous concepts that will be taught on those classes. Now let's get right into it. Now, an equation which can be written in the form of ax square plus bx plus c equals to 0, where a is non-zero and a comma b comma c are real. We call it as an quadratic equation, and generally we take a, b, c should be real values, but there are some time where a, b, c can be imaginary also. Now, an equation which can be written in the form of ax square plus bx plus c equals to 0, where a is non-zero and a comma b comma c are real, we call it as an quadratic equation. Now, there might be a solution which can satisfy this quadratic equation. We call them as the roots of a quadratic equation. This is Now let us find the roots of a quadratic equation. Let ax square plus bx plus c equals to 0 be our quadratic equation. Now, this can be written as x square plus b by ax plus c by a equals to 0 just by dividing whole equation by a. Now, this can be written as x square plus 2 times b by 2a of x plus c by a equals to 0. Now here we can make this as a perfect square by adding b by 2a whole square. That implies x square plus b by 2a into x plus b by 2a whole square minus b by 2a whole square plus c by a equals to 0. Now, this whole can be written as a perfect square. X plus b by 2a whole square minus b by 2a whole square plus c by a equals to 0. That implies x plus b by 2a whole square can be written as b square by 4a plus c by a. Sorry, minus. Now, root it on both sides. X plus b by 2a equals to plus or minus root over b square by 4a square minus c by a. That implies we get x plus b by 2a equals to plus or minus root over b square minus 4ac by 4a square. That can be written as x equals to minus b by 2a plus or minus root over b square minus 4ac by 2a. That implies x equals to minus b by 2a plus or minus root over b square minus 4ac by 2a. Now, since we got the roots, now we can find the properties of the roots. Let alpha comma beta be the roots of a quadratic equation ax square plus bx plus c equals to 0. Now alpha will be minus b by 2a plus or minus. Now alpha will be alpha equals to minus b plus root over b square minus 4ac by 2a, and beta will be minus b minus root over b square minus 4ac by 2a. Now alpha plus beta will be minus b by 2a minus b by 2a plus these two will be cancelled out. We get minus b by a, alpha plus beta. And similarly, alpha beta will be minus b whole square minus root over b square minus 4ac whole square by 2a. We get it by a minus b into a plus b equals to a square minus b square. Like that, take minus b as a, root over b square minus 4ac as b. We get this. That implies alpha beta equals to b square minus b square plus 4ac by 2a. That equals to 4ac by 4a square. That implies we get alpha beta equals to c by a. There is a special case where take Pn as alpha power n plus beta power n. Then if quadratic equation is ax square plus bx plus c equals to 0, then we can write as apn plus bpn minus 1 plus cpn minus 2 equals to 0. We can do its proof also. It is very simple. We know that alpha and beta satisfies the equation ax square plus bx plus c equals to 0. No. Now substitute alpha and beta in the equation. We get a alpha square plus b alpha plus c equals to 0, and a beta square plus b beta plus c equals to 0. Now multiply it both by this into alpha power n minus 2, this by beta power n minus 2. Now we get a alpha power n plus b alpha power n minus 1 plus c alpha power n minus 2 equals to 0, and a beta power n plus b beta power n minus 1 plus c beta power n minus 2 equals to 0. Now simply add both of that, so to get this equation. Now we will start on a small concept on complex numbers. Now, if one of the root of quadratic equation is complex, then the other root of the quadratic equation will be conjugate of the another root. That is, if alpha is root of quadratic equation ax square plus bx plus c equals to 0, then alpha bar is also a root of the equation ax square plus bx plus c equals to 0. Now we will find out the nature of roots of a quadratic equation. Let ax square plus bx plus c be quadratic equation, and we take d equals to b square minus 4ac. We call this as a discriminant of a quadratic equation. Now we know that the roots of the quadratic equation ax square plus bx plus c is are minus b by plus or minus root over b square minus 4ac by 2a. We just call this whole under root as discriminant of a quadratic equation. Now, case 1. If d is greater than 0, that implies root over d will be real. That implies both roots will be real. Now, case 2. D equals to 0. That implies root d equals to 0. That implies there is a unique root for the quadratic equation. Means both roots are equal. Means there is only one root for the quadratic equation ax square plus bx plus c equals to 0. Now the third case, important case, d is less than 0. Root, that implies root d must be imaginary. That, that implies roots of a quadratic equation must be a complex number. Therefore, we get the roots as minus b by 2a plus I root mod d by 2a. Another root as minus b by 2a minus I root mod d by 2a. If we observe them, we get to know that both roots are conjugate to each other. From here we can confirm that if discriminant is less than 0 or one of the root is complex, then we can say that the other root should be conjugate of of the root given. Conjugate means, see, if a plus ib is the root, then the conjugate of the root means a minus ib. The imaginary part will be negative, but that's it. Now we can end the theory part. Now we will go into problem solving. Now here is the first question. Let let alpha and beta be the roots of a quadratic equation x square minus x minus 1 equals to 0 with alpha greater than beta. For all positive integers n, define a n as alpha power n minus beta power n by alpha minus beta, and bn as a n minus 1 plus a n plus 1. Then which of the options are correct? Now they have said that alpha comma beta are the roots of x square minus x minus 1 equals to 0, and said that a n equals to alpha power n minus beta power n by alpha minus beta. Now we know that if we take Pn as alpha power n minus beta power n, we get Pn minus Pn minus Pn minus 2 equals to 0. That means Pn minus 1 equals to Pn minus Pn minus 2. That implies Pn equals to Pn plus 1 minus Pn minus 1. Now from here, just divide it by alpha minus beta. We get Pn minus 1 n plus 1 by alpha minus beta minus Pn minus 1 by alpha minus beta. That implies An equals to An plus 1 minus An minus 1. Now, from the question, as this is a multiple correct answer, we will go by options. The first option is a1 plus a2 plus n so on an equals to an plus 2 minus 1 for all n greater than 1. Then they are saying a1 plus n so on plus an equals to an plus 2 minus 1. Now here we can write an plus 2 as an plus 1 plus an minus 1 from the above equation here. From here Pn equals to Pn minus 1 minus Pn minus 2. That implies Pn equals to Pn minus 1 plus Pn minus 2. We can apply this. Now apply here for n plus 1. We get an plus an plus an minus 1 minus 1. That implies that can be written as an plus 1 plus an minus equals to an plus an minus 1 plus an minus 1. Now here again do it for an. We get an minus 1 plus an minus 2 plus an minus 1 plus an minus 1. Hence on. Finally we get that equals to a1 plus a2 plus hence on plus an minus 1 plus a2. Again, a2 can be written as a1 plus a naught. Here a naught equals to alpha power 0 minus beta power 0 by alpha minus beta, that equals to 0, and a1 equals to alpha minus beta by alpha minus beta, that equals to 1. That implies a2 equals to 1. We get a1 plus n so on plus an plus a2 minus 1, that equals to a1 plus n so on plus an equals to an RHS. Hence proved. Take RHS. An plus 2 minus 1. We know that an equals to an minus 1 plus an minus 2. From this, we can write it as an plus 1 minus 1. Now, again write an plus 1 as an plus an minus 1 minus 1. Again write an as an minus 1 and an minus 2. An plus an minus 1 plus an minus 2 plus an minus 1 minus 1. Again apply for n minus 1 and so on. Finally we get a1 plus a2 plus a2 plus a3 plus and so on plus an minus 1. Now we know that a1 equals to 1 and a naught equals to 0, since a naught equals to alpha power 0 minus beta power 0 by alpha minus beta, that equals to 1 minus 1, that equals to 0, and a1 equals to 1. That implies a2 should be a1 plus a naught, that equals to 1. That implies we get RHS as a1 plus hence on plus an plus a2 minus 1. a2 is 1, so cancel it. That equals to LHS. Hence, the first option is right. Now we will go for the second option. What they have said. Summation n equals to 1 to infinity an by 10 power n. Summation n equals to 1 to infinity a n by 10 power n equals to how much? Now, an equals to alpha power n minus beta power n. Alpha power n minus beta power n by alpha minus beta. That implies an by 10 power n can be written as 1 by alpha minus beta into alpha power n minus beta power n by 10 power n by taking all n's in common. That implies n equals to 1 to infinity an by 10 power n equals to 1 by alpha minus beta into summation n equals to 1 to infinity alpha power n minus beta power n by 10 power n. We know that alpha and beta must be less than 10, since uh, 10 square minus 10 minus 1 is greater than 0, and 2 square minus 2 minus 1 is also greater than 0, That implies alpha and beta must be in between 2 and 10. That implies alpha by 10 must be less than 1. Now here apply summation for individual alpha power n by 10 power n minus summation beta power n by 10 power n whole into 1 by alpha minus beta. We get 10 by alpha into 1 by 1 minus 10 by alpha, alpha by 10. We get alpha by 10 into 1 by 1 minus alpha by 10 minus beta by 10 into 1 by 1 minus beta by 10. That equals to alpha by 10 into 10 by 10 minus alpha plus minus beta by 10 into 10 by 10 minus beta. That equals to alpha by 10 minus alpha minus beta by 10 minus beta whole into 1 by alpha minus beta. That implies 10 times alpha minus beta into plus alpha beta minus alpha beta by 100 minus 10 times alpha beta alpha minus beta plus 10 times alpha plus beta into alpha beta into 1 by alpha minus beta. That equals to 10 by 100 in minus 10 into alpha plus beta plus alpha beta. From the equation x square minus x minus 1, alpha plus beta will be 1 by 1 minus of minus. That equals to 1. And alpha beta will be 1. That implies summation a n by 10 power n equals to 10 by 100 minus 10 times minus plus 1. That equals to 10 by 89. So first option and second option are right. Now we will go into third option. Bn equals to a power n minus 1 plus a n plus 1 from here. But we know that this can be written as alpha power n minus 1 minus beta power n minus 1 plus alpha power n plus beta power n by alpha minus beta. That equals to, we know that alpha beta equals to 1. Now multiply beta power n minus 1 or alpha power n minus 1 on both sides. We get alpha power n beta equals to minus beta power n minus 1. Sorry. Now, substitute the values into this. Let f of x equals to x power 4 plus ax cube plus bx square plus c be a polynomial with real coefficients such that f of 1 equals to minus 9. Suppose that I root 3 is a root of a equation 4x cube plus 3ax square plus 2bx equals to 0. If alpha 1, alpha 2, alpha 3, alpha 4 are roots of equation f of x equals to 0, then find alpha 1 square plus alpha 2 square plus alpha 3 square plus alpha 4 square. Now here they have given the equation f of x as x power 4 plus ax cube plus bx square plus c, and f of 1 is minus 9. From these two we get 1 plus a plus b plus c equals to minus 9. That implies a plus b plus c equals to minus 10. This is equation number 1. Now they have given that root 3i is one of the root of the equation 4x cube plus 3x square plus 2bx equals to 0. Clearly we know that x into 4x square plus 3x plus 2b equals to 0. Clearly we can write this into in the form of this by taking x as common. Now we know that root 3i is root of the quadratic equation 4x square plus 3ax plus 2b equals to 0. We know that if one of the root is imaginary, then the other root should be conjugate of the root. That means the another root of the quadratic equation will be minus root 3i. Will be roots of quadratic equation 4x square plus 3x plus 2b equals to 0. That means sum of roots minus root 3i plus root 3i equals to 3a by 4 minus. That implies a equals to 0. Similarly, product of the roots minus 3i square root 3 square equals to 2b by 4. That implies b by 2 equals to 3. From here b equals to 6. Now substitute a and b in equation number 1. We get a plus b plus c equals to minus 10. That implies 6 plus c equals to minus 10. That implies c equals to minus 16. Therefore, the equation will be x power 4 plus 6x square minus 16. From here we can get the roots. F of x equals to x power 4 plus 6x square minus 16. X power 4 plus 6x square minus 16 equals to 0. That implies this can be written as x square minus 8 x square plus 8 into x square minus 2 equals to 0. That implies x square equals to minus 8 comma x square equals to 2. Alpha 1, alpha 2 will be from here. Alpha 3 and alpha 4 will be from here. They asked mod alpha 3 whole square plus alpha 1 whole square plus mod alpha 2 whole square plus mod alpha 3 whole square plus mod alpha 4 whole square. That means 2 plus 2 plus 8 plus 8. That equals to 20. Now we will do the second question. Now the second question. If x square minus 10ax minus 11b have roots c and d, and x square minus 10xc minus 11d has roots a and b, then find a plus b plus c plus d. X square minus 10ax minus 11b has roots c comma d, and x square minus 10cx minus 11d has roots a comma b. Now we have to find a plus b plus c plus d. Now the equations we get c plus d equals to 10a, comma cd equals to minus 11b, and a plus b equals to 10c and ab equals to minus 11d. Now add these both two. Now, subtract c plus d into minus a plus b equals to 10 of a minus c. That implies c minus a plus d minus b equals to 10 of a minus c. That implies d minus b equals to 10 times a minus c plus a minus c. That equals to 11 times a minus c. D minus b equals to. Now, as c is root of equation number 1, substitute c in equation number 1. C square minus 10ac plus 11b equals to 0. And similarly, root a square minus 10ac plus 11d equals to 0. Minus 11d. Now, from these two, subtract one from another. We get c square minus a square equals to 11 of b minus d. That implies c minus a into c plus a equals to 11 times b minus d. But we know that from here d minus b equals to 11 times a minus c. That implies c minus a into c plus a equals to 121 times c minus a. C minus a cancelled. From here we got a plus c as 121. This is equation number 2. Now we know that a plus b equals to 10c and c plus d equals to 10a. Add both of them. We get a plus b plus c plus d equals to 10 times c plus a. But we know that c plus a equals to 121. That implies 10 into 121. That equals to 1210. Finally, we got A plus B plus C plus D equals to 1210. So that is it for today, guys. We will continue this chapter in the next class. Until then, bye.